Hello fellow viewers, in this video today we're going to be talking about binomial theorem. So the general formula for the binomial theorem is just a plus b to the power of n equals to a to the power of n plus n choose 1 times a to the power of n minus 1 times b to the power of 1, then n choose 2 times a to the power of n minus 2 times b to the power of 2, and then plus, and then it goes on in that repeating pattern, in the plus 1 pattern for the r. After that, it is n choose r to the, times a to the power of n minus r, then times b to the power of r, and it keeps on going again until we reach n choose n times a to the power of n minus n times b to the power of n. So that is a very long formula. So basically this r over here, we call this the general term. So this one can be used to find specific terms, but we're not going to worry about that now. We'll cover that later on. So this binomial theorem can be used for the expansion of binomial expansions, basically. So let's say, for example, let's try x plus 2 to the power of 4. All right. So by applying that formula up there, we will get x to the power 4 plus 4 choose 1. 4 is my n. This is my n, and then this will be x to the power of 4 minus 1 times 2 to the power of 1 plus 4 choose 2 times x to the power of 4 minus 2 times 2 to the power of 2 plus 4 choose 3 times x to the power of 4 minus 3 times 2 to the power of 3 times, plus, my bad, 4 choose 4 times x to the power of 4 minus 4 times 2 to the power of 4. So when both chooses are the same values, when you're then we will stop. We'll stop here. Yeah. So this is basically the expansion of x plus 2 to the power of 4 using the binomial theorem. So now we can further simplify. We can narrow it down. Let's make it look a bit tidier. So x to the power of 4 is just x to the power of 4, and this is 4 choose 1 is just 4, so 4 times 2 is 8, so 4 minus 1, that's 3. And then we have 4 choose 2, which is 6, and 6 times 4 is 24, and we have x squared here. And then following on, 4 choose 3. 4 choose 3 is 4, and 4 times 8 is 32, and then our variable is just x here. And for the last term is just 16. So basically, this is just x plus 2 to the power of 4. All right. So something you do notice is that the first term does not have a n choose r. All the other terms, if you do pay attention, have an n choose r in them. The only exception is the first term. It doesn't have an n choose r. All right. Okay, so we're going back to that general term I was talking about, and I said that it can be used to find specific terms. Okay, so let's go back to x plus 2 to the power of 4. So let's just say in this binomial expansion, I want to find the third term. Yeah? Okay, let's just pretend we didn't do any of that. So I'm still unsure on what the third term equals to. So now, I want you to take a look at the r value in the choose. Sorry, it's a bit laggy. Alright, so we do know that in the first term there is no choose, but Yeah. But from the second term onwards, the r equals to 1. And then in the third term, your r equals to 2. In your fourth term, your r equals to 3. And in your fifth term, your r equals to 4. So a conclusion we can make from this is that your term will equal to r plus 1. Alright? So now I am just trying to find my third term, right? So my t will equal to 3. So therefore, r plus 1 equals to 3, and therefore my r will equal to 3 minus 1, which is just 2. And for that, my r plus 1 term, which is my third term, will equal to 4 choose r, and my r is 2, so therefore, oh wait, hold on, let me just write this out real quick. Alright, yeah, so we have this. So my r plus 1 term is just 4 to choose r times x to the power of 4 minus r times 2 to the power of r. And since I know that my r equals to 2, I can just substitute the value of r equals to 2 into this expression up there. So then I will get 4 choose 2 times x to the power of 4 minus 2 times 2 to the power of 2. And by doing all of this, I would then get 6 times x squared times 4, which in turn will give me 24x squared as my third term. And since we have that finished copy up there, we can just check our answer. So 24x squared is our third term. So we can start counting from here. Our first term, second term, third term. And the third term is 24x squared. So we are correct. All right. Okay, let's do another example. Let's try x plus 2 to the power of 5. So x plus 2 to the power of 5, right? We always, something we do notice too is that the number of terms in your binomial expression is always your power plus 1. Or in mathematical terms, it's just n plus 1. Okay? So that's the amount of terms you have. So in this binomial expansion, since our power is 5, so n equals to 5, so the number of terms we will have will equal to 5 plus 1, which is 6. So in this expansion, we will have 6 terms. So let's just say I want to find... I'm a very boring person. Let's go with the third term again. I want to find the third term. So therefore, my r plus 1 term, which is my third term, will equal to 5 choose r times x to the power of 5 minus r times 2 to the power of r. Alright? And since I want my third term, we can apply that t equals to r plus 1 and my t equals to 3. So therefore, 3 equals to r plus 1 and my r will equal to 2. So now we will just substitute r equals to 2 into that expression. So 5 choose 2 times x to the power of 5 minus 2 times 2 to the power of 2. So therefore, by doing this, we will get 10 times x cubed times 4, which will give us 40x cubed. So this is my third term in this expansion. Okay, so that does it for today's video. Hopefully you know more now that the general term can be used to find specific terms in a binomial expansion. So goodbye.